right, in this video we're going to look at effective annual yield, or sometimes it's called effective annual rate, or sometimes those things are abbreviated. So if we're talking about effective yield or effective rate, they might call it that without saying the word annual. Or sometimes when you look at banks or investments, they will give an abbreviation that is APY, or maybe they might say APR. So if annual percentage yield or annual percentage rate is another way to abbreviate those. So our text calls them effective yield or effective rates, but sometimes you see it like this in business. All right, so the basic idea is that this is a way to convert interest that is compounded in different ways to an annualized rate so that it provides a way of comparing them. So we know that in general, compounding more often is a better investment, but this is a slightly lower percentage rate than these others. So this would be a good way to compare these different investments and decide, are they all the same, or is one of these better than the others, which one's best, and considering different ways like that. So there is a formula. Rather than memorizing a new formula, I tend to think about it as pieces of previous formulas that we've had. So remembering that if we're talking about compound interest that is compounded a finite number of times per year, we have a certain formula that involves 1 plus r over n to the nt in that formula. And so we're really just looking at the part that involves the interest rate, not the principal. I don't know how much was started with here. It doesn't really matter. I'm just converting these percentage rates. So in order to convert these two, we're going to use the formula that's just the percentage rate part. So 1 plus r over n to the n. Again, I don't know how long, or you can think about it as 1 here, since we're converting these all to annual. So n times 1, if you want. When you do this calculation, you'll end up with a number more than 1. And so subtracting 1 from that will give you a decimal that you can then convert back to a percent if you want. So this is the formula that I'm going to use for these first two. For the last one that's compounded continuously, again, I'm just going to use the part of that compound interest formula that involves the rate. So if you think about the compounded continuously formula, A equals P e to the RT, I don't know the A or the P. It doesn't matter what those are. It's just the interest rate part. So in this case, e to the r, and again, I'm converting to annual rate, so you can think about t being 1. This will give you a value bigger than 1, so subtracting 1 off from that, though, will give you a percentage rate. So these are the two formulas. Again, you can think about them as totally new formulas if you want to, but I kind of just think about them as pieces of the interest rate formulas. All right, so I'm going to use these formulas for these, and again, the goal is to compare these and to rank these in terms of which of these investments has the best overall interest rate, the best annual percentage yield. All right, so this first one, I will have, I'll write E for effective rate, is equal to 1 plus the R is 0.05. Compounded quarterly would be 4 times per year to the 4th power, and then subtract 1. So I did that on my calculator already. And it said that I'm going to write a whole bunch of digits here because these actually all turn out pretty close to each other, and so I'm going to need several digits in order to be able to compare them here. So for this one, I get 0.050945339. That's all the digits my calculator shows. So depending on what calculator you have, it might show a few more digits than that. All right, for this next one, compounded monthly, it's a slightly different percentage rate, so I've got to be careful about that. So 4.955%, so again, that's out of 100, so moving that decimal 2 places to the left. So 0.04955. Monthly is 12 times per year. So this to the 12th power, and then minus 1. And so for this one, I get 0.05069093345. All right, so that allows us to compare these. I'm going to go ahead and do this last one as well, and then we'll kind of talk about all three of them overall and compare which one's best, which one's in the middle, and which one is worst. All right, for continuous compounding, remember that's when we use the e function. So I'm going to have e to the 0.0495 minus 1. And again, I'm going to write all these digits down because these are all pretty close to each other. All right, so 0.05074555922. All right, so the goal of this was to compare these three investments and decide which one is better, which one is in the middle, and which one is worse. All right, so converting these all back to percentage rates, if I wanted to, I'm going to write those in a different color here just so we can see them clearly. So this first one, if I convert that back to a percentage rate, I would move that decimal 2 places over, so I would have about 5.0945%. I'll just write that many digits approximately. So about 5.09. So 5% compounded quarterly is equivalent to 5.0945% compounded once per year, annually. All right, the next one, 4.955 compounded monthly, is equivalent to 2 spaces over here, so 5.0691%. All right, so comparing those two, this first one is slightly higher interest rate. They're both a little bit over 5, equivalent to a little bit over 5, but this first one is a little bit better. And then this last one here, if I convert that to a percent, so moving 2 spaces over, we'll have 5.0746%. Just kept 4 digits after the decimal in the percentage here. So 5.07% approximately. So they're all very close to each other, but the whole idea with converting these to an annual percentage yield or APR, sometimes credit cards will call it APR because you're not getting money, they're charging you money, but they're all required to report these. But if this is an investment, this one, 5.0945% per year, is slightly better than the others. So this would be the best or the highest one. And then the one in the middle would be this 4.95% compounded continuously. And then this one is the lowest of those three. Interest rate of those three. All right, so again, formulas to memorize, but the real important part here is thinking about how to make sure that you know how to use these functions on your calculator, and then being clear about what these answers mean and what they tell you, and what information they would give you that might be practical for your everyday life.